Japan's SLIM probe has just made history with its phenomenal touchdown on the moon.
Japan has become the 5th country to land a spacecraft on the moon.
The massive project, which was years in the making, featured a new advanced technology that may revolutionize space exploration as we know it. But amidst the excitement, something dark and mysterious was noticed about the probe, something that has everyone talking. It turns out there was a lot more to this mission than the world ever knew. What happened to the SLIM probe on the moon? What secrets have been revealed about this mission, its true purpose, and its impact on space exploration? Join us in this video as we reveal everything about Japan's Moon Sniper mission. We finally found what NASA was hiding. On January 19th, the Japan Aerospace Exploration Agency, JAXA, landed its special probe, SLIM, on the moon. This phenomenal feat made Japan the 5th country ever to land a vehicle on the moon successfully. The project started as far back as 2005 with the idea of building a small lunar landing experiment satellite. By 2013, SLIM had been proposed as one out of 7 focus missions for the ISS. Fast forward to April 2016, SLIM became an official JAXA project, with Mitsubishi winning the award for constructing the spacecraft. The most important aim of the mission was to test a new landing technology. The project, if successful, would showcase a precise pinpoint landing technique that would greatly impact space exploration moving forward. SLIM's journey to the moon took about 4 months. The journey to the moon began with a ride along the X-ray imaging and spectroscopy mission X-RISM. After separating from X-RISM, SLIM changed direction, preparing to enter into lunar orbit. By December 25, 2023, it gracefully entered lunar orbit and rounded it off with one of the most perfect moon landings ever witnessed. You see, moon landings have always faced a major issue: landing at the right spot. The Smart Lander for investigating the moon was a concept that aimed to use new modern technology to carry out a perfect moon landing. The success or failure of the mission would tell if the space exploration community had a new way of landing perfectly on the moon or any other planet for that matter. The focus for NASA and other space agencies has long shifted from landing anywhere on the moon to landing exactly at a specific point. Thankfully, the mission came to a fruitful breakthrough on January 19th when the lander made a very precise soft landing on its target location. However, even though the probe landed softly, there was a power issue. You see, due to the way the probe had landed, its solar panel, which was supposed to be facing the sun, was facing another direction. As such, there was no way for SLIM to recharge. JAXA ground team had to use the backup batteries to deploy 2 rovers to take measurements of the lunar surface. In addition, the multi-band spectroscopic camera, or MBC, which was mounted on SLIM, was able to capture some images during this period. Due to the data collected from the device, JAXA was sure that the lander hadn't suffered any major damage upon landing. And so, they decided to leave the probe on the moon and wait till after the sun changed its angle to face the solar panels. Just so you know, 1 lunar day is 14 Earth days, meaning that if you were on the moon, it would take 14 whole days for the sun to rise and set. Initially, JAXA had planned to operate the probe for at least 2 weeks, taking advantage of the solar power. However, after the unexpected crash landing, all that's left to do is wait till the end of the lunar day. By then, the sun's rays would point in the direction of the solar panel, and JAXA would finally be able to harness its power for the probe. This procedure depicted by the Japanese in this mission has demonstrated that it is possible to make very precise landings on the moon. Not just that, they've also shown it is possible to make a soft landing on the moon, something that has proven difficult even for agencies like NASA. One thing NASA didn't do during its Apollo missions was to land on target. For example, Neil Armstrong and Buzz Aldrin suffered complications while landing the Apollo 11 lunar capsule. First, there were severe communication problems with the base, and then all sorts of alarms got triggered. Overall, it seemed like the automatic landing systems had failed, and Armstrong had to take manual control to land the module. Even at that, they landed in a completely wrong location. The fact that Slim landed on target is actually a plus. Most attempts to land on the moon recently have resulted in failure. Usually, when probes attempt to land on the moon, they crash. Moreover, they crash in unplanned locations. Japan's Slim, however, managed to execute a soft crash landing, so much so that the rovers could still be deployed. Just to give you an idea, imagine what would happen if a rocket suddenly loses one of its engines mid-flight. Worst case scenario, it would crash and burn. Best case scenario, it would make an emergency landing in an immediate, convenient landing spot. But, you see, although the probe lost its nozzle, it still landed right on target. This has earned Japan a very honourable position amongst fellow countries that have dared to explore the moon. So far, only China has made a successful moon landing in the 21st century. It's still a wonder why 21st century moon probes can hardly stick a landing, whereas 50 years ago, NASA was landing astronauts on the moon. Many skeptics have raised questions as to why this is, and some experts in the scientific community have come up with plausible new explanations. First, back then, there was a space race. The US and Russian governments were at each other's throats. Each country tried hard to prove its superiority over the other, and the space beyond our planet was the battlefield. NASA, fully backed by the US government, poured in tons of resources to create the best lunar capsules, rovers, and landers. Today, there isn't a space war. All nations that have completed lunar missions have done so simply out of curiosity, or to carve a name for themselves in the history of space exploration. And so, the probes or space vessels of today are done using substandard materials to minimize costs. Moreover, most landers are built by private companies. Statistically speaking, landers built by private companies have a 100% failure rate on the moon. The ice-based Japanese lander, which crashed on the moon in 2023, is a good example here. Another factor that creates problems for landers and space probes is the moon itself. Communication on the moon is a big problem since the giant white satellite always interferes with radio signals. This causes serious problems and is mostly responsible for the cases where probes land in the wrong spot. Again, the lack of atmosphere on the moon makes it impossible for a craft to land with parachutes. Everything depends entirely on the engine. The pilot or control must find a way to gradually steer the probe to land while battling communication problems. Ultimately, if the probe is too heavy, a crash is inevitable. China's Chang'e 3 lunar mission in 2013 was the first soft moon landing since Russia's Luna 24 in 1976. Most other landings from other countries like Russia have met a worse fate, and so it was high time someone came up with a solution for all the landing problems. Luckily, Japan came to the rescue. Just so you know, the Japan Aeronautical Space Agency has been a long-standing partner of NASA. As such, there's no doubt that the new Japanese guidance system would come in handy for future NASA missions. The Artemis program, for instance, which is scheduled to host the next set of humans on the moon since the Apollo missions, is surely going to feature some of this groundbreaking technology. However, there is a big problem. Something strange happened to Slim on the moon, and JSA hasn't been able to figure out why. The probe, which was carefully designed to land upright on its target, ended up landing face down. Speculations say that this mishap was caused by an external force. Unless this mystery or puzzle is solved, there will be no guarantee that future NASA missions will turn out as planned. So, what exactly happened to Slim on the moon? Right now, it's still a mystery. This JAXA probe was built to land in a very precise way. For example, its legs were equipped with crumple zones to ensure it executed a soft landing even when landing at a higher speed. The target area where this craft was supposed to land was a 15-degree slope on an impact crater. The crater is known as the Scioli crater, and the probe landed precisely on the coordinates 25.24889 east and 13.31549 south on the slope, merely 55 meters off target. This spot was chosen so that it could offer the most sun exposure. The probe's rear legs were built a bit shorter than the front legs so as to accommodate the slope. Again, JAXA programmed the vehicle to flip at an angle of 45 degrees just before touchdown so it would have a more gentle impact, regardless of the weight. In addition, it boasted 2 Mitsubishi engines and 12 attitude control thrusters. Usually, lunar probes are necessitated to have more than one engine to enable a smoother landing. Thrusters also serve a valuable purpose, to minimize the speed of descent. In the case of SLIM, the landing was designed to be in 2 stages or steps. First, the landing thrusters and a smaller thruster would be activated to tip the spacecraft to its side. Next, the 5 crushable aluminum lattice landing legs would kick in and cushion the final landing. So, in essence, SLIM had everything it needed to make a sweet landing. Sadly, however, it ended up landing on its nose, and no one knows why. One scary school of thought is that extraterrestrials may be responsible. You see, JAXA admitted it themselves that one of SLIM's engines failed right before making contact with the lunar surface. And so far as they know, the cause was an external factor. In other words, something must have tampered with the engines, causing the probe to crash land. What could be on the moon that altered SLIM's engine? Could this same external factor be responsible for the numerous other lunar crashes? Some conspiracy theorists who have long believed in the existence of aliens on the moon have proposed that these beings are responsible. However, all this is just mere speculation based on the mystery clouding the event. The actual fact remains unknown. All JAXA knows right now is that SLIM's panels are facing westward. For now, nothing much can be done for the probe unless, of course, the sun shines on our dear probe once again. The only way JAXA can know what really went down is if they get to see satellite imagery from something like NASA's Lunar Reconnaissance Orbiter. But be that as it may, compared to most other 21st century moon landings, the SLIM mission was a success. If nothing else, the level of precision executed during this mission has earned it a top rank. In most lunar landings that had been done before now, the landing sites or targets were marked in kilometers. Even then, many hardly hit the mark. For this mission, however, JAXA measured the landing site in meters, and SLIM hit the mark, deviating by just 50 meters. Again, at least SLIM was able to deploy 2 experimental rovers and use as much onboard science equipment as possible before its battery ran out. The 2 rovers, which were named Lunar Excursion Vehicles or LEVs, were unique in their own way. While LEV-1 is a frog-like rover that moves with hopping movements, LEV-2 is a small ball that splits into a wheeled camera and waggles along like how sea turtles do on a beach. LEV-1 managed to communicate properly with ground stations and also received a test radio wave data transmission from its cousin, LEV-2. However, JAXA hasn't received any images from LEV-1 yet. The LEV-2 rover was the one that captured an image of SLIM on the moon. From the image, it could be seen that the thrusters of this probe were facing upwards when they should, in fact, be facing downwards. For now, both these rovers are on standby, awaiting the days when the sun will shine on them again. If our calculations are correct, the lunar day will be approaching its end around January 31st. So, LEV-1 and LEV-2 should resume activity around this time. Just so, you know, the SLIM spacecraft cost a whopping 18 billion yen or $120 million to make. In total, it weighed 200 kilograms, with a weight of 700 kilograms after being fully loaded with fuel. The fuel here was necessary to power the thrusters during the landing process. LEV-1 and LEV-2 rovers were other aspects of the mission that were really demanding both financially and tech-wise. LEV-2, for example, has been renamed Sora-Q due to its complexity. The 0.25 kilograms rover was jointly developed by JAXA, Sony, Tomy, and Doshisha University. Currently, it is the smallest and lightest rover ever made, about the size of a baseball. Sora-Q was created using a combination of toy technology, sensor robotics technology, and JAXA's space technology. It was designed to act autonomously and adapt to the lunar environment. Speaking to the press, SLIM's project manager Shinichiro Sakai said, "We've proved that you can land wherever you want, rather than where you are able to. This will inspire more and more people, desirably Japanese missions, to try to land on unexplored places on the moon." There's no doubt that this is clearly a win for Japan's space agency. With this new technology, maybe space agencies will finally be able to send probes, rovers, or even astronauts to the far side of the moon. The far side of the moon, also called the dark side of the moon, is one place that has always been shrouded in controversy and conspiracy. Many rumors and conspiracy theories about the existence of aliens on this part of the moon have emerged over the years. From the weird structures and shapes littered all over to the weird radio interference and strange crashes from lunar missions, there's a lot about this side of the moon that seems mysterious. At one time, there were rumors that NASA had sent astronauts to the far side of the moon, only for the men to find a crashed alien ship there. Rumors have it that they brought back alien corpses, which were preserved for analysis. However, NASA has since denied such accusations, insisting that the last crewed mission was Apollo 17. JAXA's recognition on the world stage has been increasing ever since it became a trusted international partner for NASA and the European Space Agency. One major project the agency greatly contributed to was the ISS. Japan also signed on to help construct several modules for the Gateway Lunar Station. Amidst all this, JAXA has been making plans for their own missions. The SLIM landing is just one out of the many more missions to come. For instance, JAXA is preparing to visit Mars very soon. The Martian Moon Exploration spacecraft is expected to launch sometime in 2024. This probe will make a trip to the Martian moons Dios and Phobos to collect samples and data. For this mission, JAXA will use its Epic H3 launch vehicle. The H3 launch vehicle is a two-stage launch vehicle that uses liquid oxygen and liquid hydrogen as propellants. The first stage is powered by 3 engines, while the second is powered by a single engine. The first time the H3 rocket was launched was in March 2023. Everything went well initially until the rocket failed to ignite for the second stage upon command. As such, the test launch was a failure. The next planned flight will most likely be around February 2024. However, something even more massive than the H3 is being built currently, and it's going to be used for Mars too. It's called New Glenn. New Glenn is a gigantic launch booster. The 98 meters tall rocket is powered by 7 engines on the first stage and 2 engines on the second. This allows the Glenn to push nearly 50 tons of payload into Earth orbit. The first flight of the New Glenn is scheduled for sometime around August 2024. New Glenn will carry NASA's Escapade Mars mission into space. NASA is taking a bold step to fly this rocket, although it has never been adequately tested with such a heavy payload before. All of this goes to show that space exploration is evolving and becoming more interesting by the day. With Japan's state-of-the-art landing technology and NASA's outstanding quality probes and launches, there's no doubt that the future looks bright for upcoming space missions. This begs the question: did Japan send a probe to the moon to explore the next-generation planetary landing technology? Or was there something more at play? Well, there's another obvious reason why the Japanese may have sent SLIM to the moon: to explore space-based solar power. On January 11th, the United States Space Agency published a study examining the possibility of setting up solar power collection through a spacecraft in Earth's orbit and beaming that power back down to the surface using microwaves. The goal here would be to create a source of clean energy. Even though the actual costs involved in the manufacture and launch of these systems are still being speculated, many experts are considering it. If it works, it could help the United States and any other nation that adopts it to achieve net zero greenhouse gas emissions before the deadline. You see, collecting solar energy in orbit is a whole different scenario from collecting solar energy on Earth. Up there, the Earth's atmosphere is almost non-existent, so you're basically getting the purest form of solar energy. The idea of harnessing such pure energy and wirelessly transmitting it to even the most remote parts of the world is very enticing. Many space agencies, including NASA and JAXA, are making efforts in this direction. The solar technology featured in SLIM has already provided more than enough data for these agencies. All that's left is for NASA or anyone else to build on what Japan has done, and the ultimate solar energy collector can be created. However, some folks are being critical of this technology. For these skeptics, the energy from such an instrument may not be safe. And again, the cost of building and maintaining such instruments is another cause for concern. Some experts have predicted that this conceptual system will produce power at a cost of 61 cents per kilowatt hour. This is outrageous, considering that terrestrial solar plants give out energy at 2 to 5 cents per kilowatt hour. Will such a project be truly beneficial, or will it be just another means for the government and its agencies to pour money down the drain? In any case, interests have sparked recently in space exploration as more and more nations are testing their hands on attempting a lunar landing. It's like a new space race is upon us. Thankfully, JAXA's breakthrough landing will make things transition smoothly for the next generation of space explorers, regardless of who they are. In an official press statement, JAXA stated, "Although SLIM's activities on the Moon were originally expected to last only a few days, the necessary preparations for recovery will continue in order to acquire further technical and scientific data. Preparation is underway to promptly conduct 10-band high-resolution spectroscopic observations once the solar illumination condition improves and SLIM recovers by the power generated by the solar array. In the end, we will just have to wait and see how much data SLIM can extract when the sun shines on it once more. But until then, the space exploration community has scored another win, one that will be remembered for a long time. Thank you for watching another episode of Voyager. While you're still here, click on the video on your screen to see more mind-blowing videos like this one.